Have you ever been told not to touch electrical appliances with wet hands? It's not just an old wives' tale. Water is an excellent conductor of electricity. That means it allows electricity to flow through it very easily. When your hands are wet, they become much better conductors of electricity. If you touch an electrical appliance, the electricity could flow through your body, giving you a painful shock. In some cases, it can even be deadly. So, next time you reach for a light switch or your phone charger, make sure your hands are dry. It's always better to be safe than sorry. Electricity needs a path to travel, just like cars need roads. Some materials are like superhighways for electricity, allowing it to zip through easily. We call these materials conductors. Think of a copper wire. It's a fantastic conductor. That's why we use it in electrical wiring. Copper lets electricity flow smoothly with very little resistance. But some materials are like roadblocks for electricity. They resist the flow of electricity, making it much harder for the current to pass through. These materials are called insulators. Rubber is an excellent example of an insulator. That's why electricians use rubber gloves and tools. They provide a protective barrier preventing dangerous shocks. Think of it this way. Conductors are like wide open highways, while insulators are like bumpy dirt roads. Let's have some fun with a simple experiment. We're going to test the conductivity of different liquids, just like scientists do. You'll need a few things: a battery, 3 wires, a light bulb, and holder, 3 glasses, lemon juice, vinegar, and tap water. First, fill each glass with one of the liquids. Next, create a simple circuit by connecting the battery, wires, and light bulb. Leave a gap in the circuit for testing. Now dip the 2 free wire ends into the first glass of liquid. Does the bulb light up? If it does, the liquid is a conductor. Repeat this process with the vinegar and tap water. You'll discover that some liquids conduct electricity better than others. Why does this happen? It all comes down to ions, which are tiny particles that carry electrical charges. Liquids with more ions conduct electricity more easily. Did you know that electricity and magnetism are closely related? When electricity flows through a wire, it actually creates a magnetic field around it. Let's try a quick activity to see this in action. You'll need a matchbox, a compass, a long piece of insulated wire, and a battery. Carefully remove the drawer from the matchbox. Wrap the insulated wire around the matchbox several times, leaving the ends free. Connect the wire ends to the positive and negative terminals of the battery. Hold the compass near the coiled wire. What happens to the compass needle? You should see the compass needle deflect. This is because the electric current flowing through the wire is creating a magnetic field. This connection between electricity and magnetism is a fundamental principle of physics. It's what makes electric motors, generators, and many other technologies possible. Section 5. Bubbles and coatings, unveiling electricity's chemical tricks. Electricity isn't just about powering our devices. It can also cause amazing chemical reactions. Let's conduct an experiment to see this firsthand. You'll need a battery, 2 insulated wires, 2 carbon rods or iron nails, a glass, water, and salt. Fill the glass with water and stir in a generous amount of salt. The salt helps to conduct electricity better. Now connect the carbon rods to the battery terminals using the wires. Dip the other ends of the rods into the salt water, making sure they don't touch. Observe what happens. You should see bubbles forming around one of the carbon rods. This is hydrogen gas being produced. The electric current is breaking down the water molecules into hydrogen and oxygen. If you use iron nails instead of carbon rods, you'll notice something else. One of the nails will start to develop a reddish-brown coating. This is rust. The electric current is causing the iron to react with the water and oxygen, forming iron oxide, which is rust. This process is called electrolysis. It's used in many industrial applications, like producing metals, purifying substances, and even creating fuels like hydrogen. Section 6. Shiny Secrets, the art of electroplating. Have you ever wondered how jewelry gets its shiny gold coating, or how tin cans are protected from rusting? The answer is electroplating. Electroplating is a process that uses electricity to coat one metal with a thin layer of another metal. It's like giving a metal object a brand new outfit. Let's take the example of gold plating. First, the jewelry piece is carefully cleaned. Then, it's dipped into a special solution containing gold ions. An electric current is passed through the solution, and the gold ions are attracted to the jewelry. They deposit themselves onto the surface, forming a thin, even layer of gold. Electroplating is used for many purposes. Decoration. Adding a layer of gold or silver makes jewelry and other objects look more attractive and valuable. Protection. Coating metals like iron and steel with zinc or tin helps to prevent rust and corrosion. Improving conductivity. Applying a thin layer of a highly conductive metal like gold can improve the electrical conductivity of components. It's amazing how electricity can transform the appearance and properties of materials. Section 7. Stay safe, stay powerful. Electricity in our lives. Electricity is an incredible force that powers our modern world. From the lights in our homes to the computers we use every day, electricity makes our lives easier and more connected. But with great power comes great responsibility. It's essential to understand the potential dangers of electricity and how to stay safe. Never touch electrical appliances with wet hands. Water conducts electricity, making it easier for you to get a shock. Don't overload electrical outlets. Plugging too many devices into one outlet can overheat the wiring, creating a fire hazard. Keep electrical cords away from heat and water. Damaged cords are dangerous and should be replaced immediately. Always unplug appliances when not in use. This reduces the risk of electrical fires. Be careful around power lines. Never climb trees or fly kites near power lines. By following these simple safety tips, we can enjoy the benefits of electricity while minimizing the risks. Section 8. Power up your knowledge. Key takeaways and next steps. Congratulations! You've learned about the fascinating chemical effects of electric current. Here's a quick recap of the key points. Conductors and insulators. Conductors allow electricity to flow easily, while insulators resist the flow. Conductivity of liquids. The presence of ions determines how well a liquid conducts electricity. Magnetic effect of electricity. Electric currents create magnetic fields around them. Electrolysis. Electricity can cause chemical reactions, like breaking down water into hydrogen and oxygen. Electroplating. Electricity is used to coat one metal with a thin layer of another metal for decoration, protection, or improved conductivity. Now it's time to power up your knowledge even further. Review the chapter in your textbook, practice answering the questions, and explore more about the amazing world of electricity. Remember, learning is a journey, not a destination. Keep asking questions, conducting experiments, and exploring the wonders of science.